hopefully have a good understanding of what an algebraic inequality, how we read it, what it represents. We're going to start solving them now. So in lesson 2.2, we're going to be solving inequalities by adding or subtracting. So solving inequalities by adding or subtracting actually follows the same rules as solving equations. It's just that the equations we've solved so far only have one solution, so we haven't been graphing them. We're going to be solving and graphing because there's more than one value that makes the inequality true. So we're going to follow the same rules. Undo addition with, what undoes addition? Subtraction. So if something's being added, we can subtract it to undo it. We can undo subtraction with the addition of the same thing. Addition and subtraction are inverse operations. They undo each other. Remember though, if we have a negative being added, we don't have to try to subtract. We can just say add its opposite. So if there's a negative number being added to the variable, we'll just add the opposite of that negative to undo it. Okay, let's go to work practicing some of these together here. So we have the inequality. X plus 1 is less than or equal to 10. So we'll show our steps of work to get x alone. 1 is being added, we'll subtract 1. That gets our x alone is less than or equal to 10 take away 1, 9. Here's our solution. This is our algebraic solution. If I asked you for the algebraic solution for this inequality, you'd say x is equal to, or is less than or equal to 9. X can be any number in that, from that solution. So now when we make our number lines, we're going to draw our number line. We're going to put a tick mark, about in the middle. We're going to give our endpoint the name of 9. The tick mark is going to be 9 because that's our endpoint. Right now, remember, we're just getting the number line set up. We're really not doing any graphing yet. And then we're going to look about equal distance from. We don't have to get out a ruler and measure, but we need to show good number line sense. We're going to show the integer neighbors left and right. So integer neighbor to the left, 8. Integer neighbor to the right, 10. So again, we really haven't done any graphing here. We're just getting ready to graph. We're setting up our number line. So now we're going to show, we're going to put our circle at 9 and decide if 9 is included. Can x be 9? Yes, it can because of the equal to bar, so we'll color it in. And then what else can x be? X can be any number that is less than that, so we would shade showing that all of these other numbers on the number line are also a part of the solution. So we have our algebraic solution, we have our graph representation of it. Okay, let's move on to number 2. Okay, in number 2 we have 2.5 is greater than negative 3 plus y. Now remember, we can read addition backwards. So we could read this as the same, it means the same thing, y plus a negative 3. So we have a negative number being added to y, so we're going to add the opposite of that to undo it. So we're going to add 3 to both sides. We have 5.5 over here. We have to keep the order though that this inequality is in. 5.5 is greater than y. So this is one of those times where the variable doesn't end up on the left side, it's on the right side instead. So again, remember, we have the option of, this also could be written, y, the y and the 5.5 trade places, the inequality symbol flips over. So if you don't like it going that direction, the way that it ended up for us, It also means y is less than 5.5. Instead of 5.5, it's greater than y. Okay, let's set up our number line. Let's show what part of the number line do we want to be at. We need a 5.5 here. And then we're going to have integer neighbors. We want about 5.5 is a half of a unit away from, like my representation there. I'm going to get rid of that. Make it a little bit better. Looks like it should be about right there instead. Integer neighbors, so we have a half a unit of distance from 5.5 down to 5. We have a half a unit of distance between 5.5 and 6. We're going to put our circle at 5.5 and decide whether 5.5 should be included in our solution. It is not included in our solution, no equal to bar, so we have to leave it open. This says, when we read it this way, in this one, it says 5.5 has to be greater than all the numbers you shade for y. So 5.5 is greater than all of these guys. Okay? Or if we look at it over in this one over here, it says y, the shaded region, all the numbers for y have to be less than 5.5. And that's exactly what we have shaded here. We have all the numbers that are less than 5.5. Okay. Let's go on to number 3. N, take away 3 5/10 is less than negative 7 5/10. So we need to undo subtracting 3 5/10, so we will add 3 5/10 to both sides. Okay, and again, we try to work without a calculator. N is now by itself is less than negative 7 5/10. I can think of that like money. It's like I owe somebody $7.50. Add 3.5, that's like paying them back $3.50. If you owed somebody $7.50, paid them back $3.50, you wouldn't still be to the good, you'd still owe them money, and you would owe $4, so negative 4. So our solution is n is less than negative 4. Okay, let's get ready to do our graph. We need a tick mark with negative 4 labeled. Tick mark's about equal distance. I keep doing that same thing. I don't do a very good job of my equal distance that I tell you to do. So, which integer neighbor is to the left of negative 4? Negative 5. Integer neighbor to the right? Negative 3. We have our snapshot of the part of the number line we want. Now we're ready to show our solution on it. We're going to show it ready to graph. Put a circle at negative 4. Negative 4 is not part of the solution region. It says n has to be less than negative 4. So we shade all the numbers that are smaller than negative 4. So what should really happen is any number we take from our shaded region, whether it be the endpoint itself that is shaded in, or the shaded part that goes from that endpoint, any number from that should make the inequality true. So we can pick any number from, let's take negative 5. Let's try negative 5 from this one. We're going to put negative 5 in here. If we put negative 5 in for n, and we took 3 5/10 away from it, or took 3 1/2 away from it, so it's like you owe somebody $5, you borrow another $3.50, now you owe them $8.50. So is a negative 8 5/10, is that less than a negative 7 5/10? Negative 8 5/10 is smaller than negative 7 5/10, so it makes it true. So that's just like a checkpoint. That's a way to check to see how well we did. Okay, let's look at number 4. In number 4, I'm going to say that what we should do first is we should change this to an add the opposite. It's subtract a negative 4, so let's change it to an addition problem. X plus The opposite of negative 4 is positive 4. We're not solving yet, we're just renaming. It just looks better this way. X plus positive 4. Now it's going to be pretty easy to solve. Add 4 to undo that, we need to subtract 4. So we'll subtract 4 from both sides. What happens when you have 4 take away 4? You have 0. Is less than or equal to x. So again, this is one of those times where the variable ends up on the right side. So we have the option of saying, you know what, I like it better over on the left, so I'm going to have the x and the 0 trade sides, and my symbol has to flip over. Okay, and now we'll get our number line set up. Our first tick mark is going to be 0. Our next tick mark is going to be 1 to the right and negative 1 to the left. Okay, now we're ready to graph. We need to circle at 0. Do we want 0 included in the solution region? We do because of the equal to part. We want 0, and then when we read it from this one, we want 0 to be less than all the numbers in the shaded region. So 0 has to be smaller than all of the numbers in the shaded region, so that should mean this. If we look at it in this one, that one says it this way. X has to be greater than or equal to 0. So all of the numbers that x can be have to be greater than 0, or it can be 0. So we use the same steps, same process as if it was an equation whenever we have to undo addition or subtraction. The only difference is we're not done with these until we also show the graph representation. Okay, let's go to the back side. Okay, now we're going to write an inequality to represent each statement. Then we're going to solve it and graph it. So number 5, 4 greater than a number x is greater than 2. Okay, so we're going to need to take this and write an algebraic inequality for it. So we need 4. We can represent that with the number 4. Greater than. Notice there's not the word is there. It doesn't say 4 is greater than. It says 4 greater than. That means the operation addition. 4 greater than a number x. Okay, we'll put x next. Notice what it says here. Is greater than. There's our inequality symbol. Is greater than 2. So we have to make sure that we can replace the words with the appropriate symbols. Okay, so now we're ready to solve. We can read addition backwards. 4 plus x is the same as x plus 4. So we see that we need to subtract 4 to undo adding 4. And we're going to have x alone. And whatever 2 take away 4 is our endpoint, negative 2. Here's our algebraic solution for this. And let's put our number line over here. We need a negative 2. We need a negative 3 to the left. We need a negative 1 to the right. What do we do with our circle at negative 2? Do we shade it in? We don't, because we don't include negative 2. It says x has to be greater than negative 2. So we shade all the numbers that are greater than, more than negative 2. Okay. So let's just pick a number and see if it makes sense back in the sentence that it started with. Let's take a number from this region, like 0 would be in our shaded region. Let's put it up here and see what happens. 4 greater than 0, so that would be 4 plus 0 is greater than 2. Yeah, 4 plus 0 is 4. 4 is greater than 2. Okay, let's do a number 6. A number, n, decreased by 9 is at most 5. That sounds like a different way of saying that inequality right here is at most. I remember from yesterday. Okay, let's start back at the beginning though. A number n decreased by, sounds like we need to subtract, 9 is at most, so in other words it can't be any more than that, is at most 5. It can't be any more than 5. But it can be 5, so is less than or equal to 5. If you look back at yesterday's notes at the beginning of them, that was one of the word phrases for our is less than or equal to symbol. Okay, now we're ready. That's our setup. That's our algebraic inequality, and now we're ready to solve it. We're going to add 9 to both sides. And our solution is going to be 5 plus 9, 14. So n is less than or equal to 14 is our solution. And we'll represent that on a graph. So we need a circle at 14. N can be 14, so we're going to shade it in. And n can also be anything less than that, so all of these guys to the left are part of the solution region also. Okay, let's go to number 7. 7 less than a number is, notice there didn't say 7 is less than, it says 7 less than a number, r, is at least, there's our inequality, 10. So we need 7 less than, oh, this is the operation subtraction. But remember back when we did these, that means 7 has to be less than something else. It has to be taken away from something else. So 7 gets subtracted from the number r. That's a messy subtraction sign. 7 subtract r, 7 less than a number, 7 taken away from r, is at least. In other words, it has to be 10 or more. If I say I'm going to give you at least 10 bonus points, you're going to get 10 or 11 or 12 or, so is at least, so it is greater than or equal to 10. So if we look back at yesterday's notes in that beginning where we gave some word phrases for these inequality symbols, that should be in the list for is greater than or equal to. Okay, and now we'll just solve this. We will add 7 to both sides. And we're going to have our solution, r is greater than or equal to 17. And then we will give our graph representation of the solution. So our circle at 17, r can be 17, so we're going to shade that in. R, though, also has to be something greater than 17 is the other option. It can be 17 or it can be something greater than 17. Okay. And we have one last one to do here together. Okay, so we have 8 increased by a number, y, is no more than 4. Okay, so we need to look at these and say increased by, that would be our operation, is no more than would be our inequality symbol. So we have 8 increased by a number, y, well, that's one long addition symbol, okay, is no more than, so that means it can't be greater than 4, it would have to be less than 4, is no more than 4, it doesn't say it can't be 4, it just says it can't be more than 4, is no more than 4, so is less than or equal to 4. Okay, and now we could read this backwards. Instead of 8 plus y, we could say it's y plus 8. So we need to subtract 8 because 8 is being added to the y. And we have y is less than or equal to 4 take away 8. That would be negative 4. It's 4 above 0, the temperature drops 8 degrees, it's now 4 below. Okay, there's our algebraic representation of the solution. Now let's have our graph. So which integer neighbors? Integer neighbor to the left, negative 5. Integer neighbor to the right, negative 3. Circle at negative 4, decide if it should be included. Y can be negative 4, or it has to be less than, any number less than negative 4. Okay, so there's your skill that you're going to be practicing today in your homework. You're going to be solving inequalities that involve addition or subtraction, and not only solving them, but representing them with a graph, and sometimes even having to set up your own before you go about solving it. So good luck.